Hello everyone. In this video, we will discuss about amides, or you can call it amides, right? So amides are very easy chapter because this is something that you have already seen before. So amides are pretty much similar to esters. So if you have studied well with the esters chapter, then it's gonna be a piece of cake for you. So let's do a quick recap. What is an esters? So esters can be made by reaction of carboxylic acid with an alcohol, right? So if you have a carboxylic acid and an alcohol like this, then you can get rid of the water and snap them back in CS3, CO, and the oxygen and CH3. So this portion here is coming from our alcohol and this portion is coming from our carboxylic acid. So that is an ester. So the functional group for ester is, this is the functional group for esters. So this is our ester functional groups, all right? So similarly, amides can be formed with a similar type of scheme. So let's draw it out here. So it's gonna take a carboxylic acid and then it's gonna take an amines. So we're gonna start with the simplest nitrogen containing compound, which is ammonia. So this is our carboxylic acid. So this is, what is it? 2 carbon atoms. So this is our ethanoic acid. And the nickname for this one is acetic acid. Acetic acid. And this is our ammonia. So I'll show you in a second. We can use any type of amine as well, primary or secondary amines. Uh, so let me color code this. That way you will see the difference. N, H, H, and H. So if you just apply heat to it, and we're gonna follow the exact similar scheme that we did on the right side. So all we are doing here is getting rid of water. So when we do that, we can snap them back in. CS3, CO, then the yellow portions, which is gonna come from this. Okay, so this is our amide, right? So this one is called primary amide. So this one is an example of primary amide. And why is that? Because it is connected. So the nitrogen here is connected to only one carbon atom. So I'm just gonna different color. So nitrogen here is connected to one carbon atom, just like with amine. This is gonna be a primary amide, right? So we're gonna see secondary and tertiary amide in a second. So how are we gonna name this? So when we name this, we're just gonna follow a few key principle here. So first rule is find the carboxylic acid portions. Or in simple term, the portion that is connected to carbonyl. All right, so this is one. So how many carbon atom we have here? So we have 2 carbon atoms. So 2 carbon atom is ethane. And then we're gonna replace E with with amide. So all we're gonna do is take the ethane, then replace the E with amide. So the name is ethnamide, right? Ethnamide. Okay, so now let's make it slightly more complicated example. So there will be a third rule that's going to comes into play. So let's do another examples. So let's say this time we want to do something different, right? So let's say we want three carbon atoms. So we have CS3, CS2, COOH. So what is this one? So you have one, two, three carbon atoms. So that's propane, propane. Uh, but the E would be replaced by oic acid. So it's propanoic acid. And then let's say we're going to use a primary amine this time. So let's say we're going to use NCH3, H, H. So this is a primary amine, right? Because it is connected to one carbon atom. So this is a primary amine. Uh, what shall we name this one? So let's do a common name for this one. So this one would be a methyl group right here, and this is an amine. So common name for this one would be methyl amine, or you can call it methnamine. Yep, checking my spelling is correct. So you can call it methnamine. Okay, so we're gonna follow the exact same principle. You take out water and snap them back in. So nothing changes on the left side. CS3, CS2, CO, and nothing changes on the right side as well. N, CH3, H. So this is an amide. So the amides are basically a linkage like this. So amide is if you have a carbonyl, anything can be attached to the left, and there has to be a nitrogen, and anything can be attached to here. So when you have a functional group like this is called amide functional group. What is an ester functional group? Ester functional group is you have a carbonyl, anything can be left. To the right, there is an oxygen, and to the right of the oxygen, there has to be a carbon chain, because if it's a hydrogen, then that becomes carboxylic acid. So you want to make carbon chain on either side. Okay, so that's amide. So let's try to name this one. So first thing is look at the portion that is coming from carboxylic acid, which is in this case, this is the portion that's coming from carboxylic acids, right? So the blue portion is the one coming from the carboxylic acid. So how many carbon atoms that is? Three carbon atom. Three carbon atom is propane. Then the E is replaced by amide, propanamide. Okay, so this is gonna be our parent name. Okay, what is the substituent here? So now the nitrogen doesn't have hydrogen anymore. It has a methyl group. So this group is gonna act as a substituent. So this group's gonna act as a substituent. So what we're gonna do is we're gonna write this as a substituent. So what is the substituent here? It has one carbon atom. So one carbon atom is meth. And when alkyl group is substituent, we're gonna call it methyl. So the actual name would be methyl propanamide. Okay, so one thing is missing here. So we gotta assign where exactly the methyl group is attached to it. So the methyl group is attached to the nitrogens. So the methyl group is attached to the nitrogen. So it's gonna be N-methyl propanamide. All right, so N-methyl propanamide. So let's figure out what kind of amide is this one. So if you look carefully, the nitrogens connected to two carbon atom, one to the left. So the nitrogen is connected to carbon atoms, one to the left and one to the right. So if it's connected to two carbon atoms, so nitrogen is connected to two carbon atom. So this means this has to be secondary amide. All right. Okay, so let's do another problem, one last problems. I'll give you a name and then I'll ask you to find the structure. So let's do something like this. Uh, N diethyl butanamide. All right. Okay, so we're gonna fragment this one after another. So first thing, butanamide. So this is our parent. And parent has how many carbon atoms? It has 4 carbon atoms. So let's do it. C, 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 C. And the last one is always gonna be CO, right? And that's the portions that's gonna connect it to the nitrogen side. Okay, so this is an amide, so there has to be a nitrogens. N, and obviously nitrogen can have always 3 bonds, right? Then what are the substituent here? Substituent is ethyl, so this is substituent. So if it's ethyl, how many carbon atom? Eth has 2 carbon atoms, C double bond C. And if you look at the substituent, where the substituent location is, it's on nitrogen. So that's why it says NN. That means both of the ethyls are on nitrogens. So I'm gonna do this, 2 here, 2 here. And that's it. That's our uh, amide structure. So all we're gonna do right now is add hydrogens. So carbon has already 4, nitrogen has already 3. Uh, okay, so if I add hydrogens, hydrogens. Okay, so this is our expanded structure. So if you're asked to draw the condensed structure, so you can do this. CS3, CS2, CS2, CO. So this is the portions that came from the carboxylic acid. And the amine is gonna come from CH2, CH3, CH2, CH3, right? So what kind of amide is this going to be? Let's ask these questions. So the nitrogen is connected to 3 carbon atoms. So 1, 2, 3. So that means this has to be a tertiary amide. So this is exactly kind of your amines. All right, so that's pretty much what we're gonna do here. Let's stop here.